Hello, welcome again. We are solving some conventional questions for theory machine. The topic is Governor. Question number 68 from Civil Services Mains 2018 is the arms of a Hartal governor are of equal length. When the sleeve is in the mid position, the masses rotate in a circle with a diameter of the arms are vertical in the mid position, neglecting friction. The equilibrium speed for this position is 360 rpm. The maximum variation of speed taking into account is to reach 6% of the mid position speed for the maximum free movement of 30 mm. The sleeve mass is 5 kg and friction at the sleeve is 35 Newton. Assume that the power of the governor is sufficient to overcome the friction by 1% change of speed on each side of the mid position. While neglecting obliquity effect of arms, find the following: 1. Mass of each rotating ball. 2. Spring stiffness. 3. Initial compression of spring. Okay. Suppose this is the mid position of the sleeve and arms are vertical and horizontal. Okay. There is no obliquity of arms. So at this position the sleeve is trying to move up, so that it means that the rotation speed is maximum at this position. So this is omega. And as sleeve is trying to move up, so the force of friction will be acting in downward direction. Other forces are spring force and weight of the sleeve. Okay, so half of the confusion will divide by 2. Other half is this, because we are taking left half. And omega 1 is maximum speed and r is mean radius. So when there is no lifting of sleeve, then the speed is omega. That here rpm is given, that is 360 rpm. So from this we can calculate omega. Omega is 37.7. So this is the speed when there is no lifting of sleeve. Okay, when there is no lifting of sleeve. Okay, and it is given that assume that the power of the governor is sufficient to overcome the friction by 1% change of speed on each side of the mid position. So when the sleeve is trying to move up, the omega 1 becomes 1.01 of omega. So that is the speed when there is no lifting or no lowering of sleeve, and that is the omega 1 is the speed when it tries to move up at the mid position. Okay. So omega 1 is at 37.7 into 1.01. Okay. So now taking moment about this point, so m is so it will be f1 into a plus f1 into a counterclockwise, and this is clockwise, so mg plus fs by fs plus f by 2 into b. Okay, and this is your clockwise, this is counterclockwise, this is clockwise. Okay, so now a and b are given same, horizontal and vertical arms are same, so a and b are same, so a or b will cancel out. Okay, and mg is 5 into 9.81 and fs is unknown and f is 35. Force of friction is given as 35. Okay, so from this this is the equation number 1, and radius is given as 0.150 by 2, or as diameter is 0.15, so radius is 0.150 by 2. Okay, so this is equation number 1. So now when the sleeve is trying to move up, the force of friction will be acting in downward direction, and when it is trying to move down, the force of friction will be acting in upward direction, so it will be minus here, and the speed here it will be minimum speed as opposed to this omega 2, and omega 2 at the minimum speed at the mid position is mean speed into 0.99. Okay, so this is your m into 0.15 by 2 into 37.7 into 0.99 here. Okay, so a and b will cancel out, so this will be 1 by 2, 5 into 9.81 plus fs minus 35. Okay. So now subtracting 1 from 2 will be your n into 0.075 into 37.7 square, 1.01 square minus 0.99 square will be equal to 1 by 2, 35 by 33. So 8 m will be your 8.21 kg. The mass of the ball is 8.2 kg. Just forming two equations. Here the sleeve is trying to move up, here the sleeve is trying to move downward at mid position. So for up movement the F is positive and for down movement it is negative. And then solving these two, so M will be here 8.21 kg. Okay. So now in extreme position, so now this is the case when the sleeve remains at the mid position. So when there is extreme position, then the A arm will come here, radius will be maximum. Okay, R1 will be maximum. Okay, and suppose it is R2 and the speed will be maximum, and suppose this is omega 2 dash. And at the extreme position the sleeve is further trying to move up, so the speed at this will be maximum and minimum. Okay. So that speed is called omega 2. Okay. So omega 2 is your as it is given that the maximum variation of speed taking friction into account is 6%. So this speed will be 30 means 1.06 of mean speed. Okay, so that is 37.7 into 1.06. Okay, for maximum speed. And as the maximum speed will occur when the sleeve tries to move up, so F will be in downward direction. So here it will be in downward direction. And at the position the spring force is for F2 because position has been changed. There is displacement of sleeve here. Okay, so as 5 into 9.81 and F as 35, A and B will cancel out, and this is the maximum radius is maximum radius can be found by using that sleeve movement. Sleeve movement is given as 30 mm. So mean radius is 0.075. So this is your sleeve. So A and B are equal, so maximum sleeve movement will be starting from downward to upward. So that is 30 mm. So if it is 30 mm, okay, so then this will also be 30 mm because they are connected. This will also be 30 mm. Okay. So from mid position it will be increased by 15 mm here, and for the minimum radius it will decrease by 15 mm. Okay. So it will be 0.075 plus 0.03 by 2. Okay. And this will be your omega 2 square. Okay, this is R2, this is omega 2 square, and this is M. The mg is same, F is same, so we can find out Fs2. So Fs2 is your 2275.8. Similarly for minimum speed, suppose minimum speed is omega 1 dash, that is 37.7 into 0.94, and minimum radius is 0.075. Here it is plus, so here it is minus. Okay, so here it is Fs1, because the position of the sleeve has been changed, so Fs1 comes out as 1, 2 to 3.2 Newton. Okay, minimum speed means minimum speed will occur when it is here, and it is trying to further go down, so F will be minus here. Okay, so now this is Fs1, and this is the initial position of the governor also. Okay, and this change in spring force is Fs2 minus F plus 1, and H1 into S is your spring force. So S is spring stiffness, H1 is 0.03, so as compared to this, and initial compression is Fs1 by S, so that is 34.86.